Good day. I'm going to continue with the exponential expressions, but we're going to look at the one that is adding and subtracting. Now, this one is a little bit more difficult because there is the one thing that happens whenever you have an addition or a subtraction, like in this one in the middle at the top. It means you are going to have to factorize. Now, like all of you know, there's different ways to factorize. We start off with a common factor, or we start off with a difference in squares, or even a trinomial. So we have to decide what type of factorization are we going to use here. Now, you do that by looking at the ground number and the exponent that is a variable. Now, if all of them are the same, like in this case, 2 to the power x, 2 to the power x, 2 to the power x, it means you are going to have a common factor. Same exponent and ground number. Means it is a common factor. So factorization that is going to have to take place in this case is we are going to have to take out a common factor. But if you look at what you have there, you have a ground number with an expanded exponent. It's not just 2 to the power x. It is 2 to the power x minus 3. So what we had originally was 2 to the power x times 2 to the power minus 3, because that's the only way they could get 2 to the power x minus 3. That was the rule of exponents that we had. If the ground numbers are exactly the same and they are multiplied, then you add the exponents. Now, what we are going to do is we are going to work from this side to this side. So we're going to actually split the exponents, the powers. Okay. So that's going to be our first thing. We're going to say this is 2 to the power x times 2 to the power negative 3 minus 3 times 2 to the power x times 2 to the power of 1 divided by 2 to the power of x times 2 to the power of minus 2. And now it would enable us to take out the common factor at the top. I'm not taking out anything underneath because there's no plus or minus underneath. I'm only taking out 2 to the power x at the top. Then I still have 2 to the power minus 3 minus 3 times 2 to the power of 1, because that one and that one was moved to the front. And underneath, I have 2 to the power of x times 2 to the power of minus 2. Now, what I do is I cancel this 2 to the power x at the top and the bottom, and all I'm left with is real numbers with powers. And that you can work out on your calculator. And this means it is actually 1 over 8 minus 6 divided by 1 over 4. And that gives you minus 47 over 2. And I obtained that answer by making use of my calculator. So when you get a plus or a minus, it's first deciding what type of factorization, because whenever there's exponents with pluses and minuses, there's going to be a certain type of factorization. In this case, it was a common factor because of the 2 to the power x, 2 to the power x, 2 to the power x. They were all the same, therefore we had a common factor. Now, if I do another one, I give you 9 to the power x minus 1 over 3 to the power x plus 1. Now you can see the numbers are different. Okay, we know it is going to be factorized because of the minus and the plus. But the numbers, the ground numbers, are not the same. The one is 3 and the other one is 9. So I'm first going to change 9. I'm going to say 9 is 3 to the power of 2 x minus 1 and 3 to the power x plus 1. Now in this case, because the 1 is 2 and there's a minus and there's one other term which is 1 times 1, it is a difference in squares. So if you have different exponents or different ground numbers and exponents, then you have a choice. It's either a difference in squares which this one is, because there's only 2 terms, or it is a trinomial, which this one is not, because for a trinomial I need 3 terms. So difference in squares means I have 2 brackets. One bracket is positive, the other bracket is negative. 1 is 1 times 1, and 3 to the power 2x is 3 to the power x and 3 to the power of x. Because when I multiply them, I add the exponents, and x plus x gives me 2x. And underneath, I have 3 to the power x plus 1. It means this denominator is cancelled with that numerator, and all that I'm left with is 3 to the power x minus 1, which is my final answer for this one. If we continue, and I do the following one. Four to the power of x minus 4 times 2 to the power of x plus 3 divided by 2 to the power x minus 1. Can you see there's 2 of them that are the same? it is 2 to the power of x and 2 to the power of x. They are the same. But this 4 to the power x is different. So there's no common factor because there is a difference in the ground numbers and the exponents. So the first thing I'm going to do is I'm going to change that 4 to the power x into 2 to the power 2x minus 4 times 2 to the power of x plus 3 over 2 to the power x minus 1. Now, this means this is a trinomial. And remember, all of them usually 99.9999% of the time will be able to cancel out. So I know one of the brackets at the top is going to be 2 to the power x minus 1, because that's a bracket that I have underneath. So the other one must also be 2 to the power x in order to get 2 to the power of 2x. That plus in front of the 3 indicates that the signs are the same, so I'm going to have minus. And the only way I can get 3 is 1 times 3, and there I have factorized that numerator. And now the bottom and the top can cancel out, and you have 2 to the power x minus 3 as your final answer. So remember, please, plus and minus is always the difficult one, which means you have to factorize. And that factorization can be a common factor, which happens when the ground number and the exponent are the same throughout the whole question. The second one is the difference in squares, which happens when you only have 2 terms. And the third one is a trinomial. And in all of these cases, the something must cancel out with something underneath. So you will be able to cancel them out. In the next part, I will give you a few examples of this to do on your own.